In this video, we will be covering the basics of logarithms. So here are the basic things that I'm going to be covering today. So the first thing we'll be going over is log basics and the basics of the logarithm formula. Then we will go into special cases of logs, the product rule, the quotient rule, change of base formula, and the power rule. Let's go ahead and get into it. So here we have our basic log formula. So as you see, we have log base b of a is equal to x. So in other words, when we're using a log function, we're actually trying to solve for the exponent. So you can see we can rewrite this as log base b. That'll instead, our base will be b, our exponent will be x in this case, and then a will be what we're solving for. So down below we have an example of this. We have log base 10 of 100 is equal to 2. That's because 10 squared is equal to 100. There's another note I would like to make here. So we can actually assume log base 10. And what I mean by that is that we can, instead of writing out log base 10, we can write this out as log of a is equal to x. If we just write that, it's always assumed that this is base 10. So I want to go ahead and get into some special cases of logarithms next, namely 0 and 1. So here we have log base 7 of 0, and of course this is undefined. And while that may seem unintuitive at first, let's go ahead and let's write this out. So we have 7, and we're going to raise this to some power to make it equal to 0. I do not know of a number that we can do this with. If you do, please let me know down in the comments below. But as far as I know, 7 raised to something will never equal 0. The next one I want to get into is log base 4 of 1 is equal to 0. So this is going to rely a bit on you knowing your exponential rules, but anything raised to 0 is of course going to be equal to 1. Doesn't matter what number we have in the base here. It could be 7 million. And if we raise it to 0, it's still going to equal 1. That's just a basic rule of exponents. So let's go on to the product rule. We have log base b of a is equal to x. And we can go ahead and split this into two separate logarithms if that helps us solve an equation. So this is assuming that g times f is equal to a. But we can split it into log base b of g plus log base b of f is now equal to x. So let's go ahead and dive into an example. So let's say that we have log base 5 of 125. And I can't necessarily figure out what power we need to raise 5 to get 125. What we can do then is change this to two numbers that multiply to equal 125. So let's go with, we keep the same base, log base 5 of 25 times 5 will give us 125. So we'll split this into log base 5 25 plus log base 5 times 5. 25 times 5, of course, 125. Then all we have to do is find what power we need to raise 5 to get 25, and what power we need to raise 5 to get 5. So when we do that, we'll find that log base 5 of 25 is going to be 2, and then log base 5 of 5 is, of course, 1. So 5 raised to the first power gives us 5, and 5 squared, or 5 raised to the second power, is going to equal 2. So then we can find log base 5 of 125 is going to equal 3. So here we have the quotient rule, and it reads as log base b of a divided by y is equal to x. And we can rewrite this as log base b of a minus log base b of y is equal to x. So basically, we're just going to take the a that we have right here, and we're going to put that in front, and then the y will go to the back, and we're just going to subtract the two. Let's go ahead and get into an example. So let's go ahead and work through log base 3 of 27 divided by 9. And I can't really figure that out in my head at the moment. So let's go ahead and rewrite this. Let's go ahead and rewrite it as log, and we will maintain the same base, of 3, 27, and then we'll subtract log base 3 of 9. So now what we're going to look for is what are we going to have to raise 3 to get to 27. And of course that's going to be 3 cubed. So log base 3 of 27 will be the power that we need to raise 3 to get to 27. So 3 to the third power is going to be 27. And then 3 to the second power will give us 9. So the answer here is actually going to end up being 1. So log base 3 of 27 divided by 9 is going to equal 1, based off of the quotient rule. So let's move on to the change of base formula. And that goes as follows. Log base b of x is equal to log base c, so whatever we change our base to of x, divided by log base, once again, whatever base we're changing to of b. Let's go ahead and dive into an example. So for our example, let's go with something like log base 8 of 4. Okay? So I don't necessarily know what power I have to raise 8 to make it equal to 4. And that's usually the situation where change of base formula is going to come in handy. So I want to go ahead and change my base 8 to 2. So we'll just plug it into our formula. So we have log base 2, because we're changing to 2, of 4, and that's going to be divided by log base 2, once again, of 8. So now what we're going to be looking for is what makes 2 equal to 4. So 2 times itself, how many times is going to equal 4? And that's going to be 2 to the second power. So our first part of this answer is going to be 2. And then we're going to be dividing by whatever 2, however many times we have to multiply by itself by, is going to equal 8. So 2 to the third power will give us that. So our answer in this case of log base 8 of 4 is going to equal 2/3. So we're going to end off this video with the power rule. And the power rule basically goes as follows. Log base a to the z power is equal to x. And we can rewrite that as z times log base b of a is equal to x. Let's go ahead and get into an example. Let's say that we have log base 2 of 8 to the second power. So according to our power rule, all we have to do is drop our 2 out front. Then we have 2 times log base 2 of 8. So the order of this does matter. So we're going to take the logarithm first. So 2 raised to what power is going to give us 8? So 2 times itself, how many times is going to equal 8? So that's going to be 2 to the third power. So then we have 2 that we have from the top where we dropped out front, and we're just going to do simple multiplication. So 2 times 3, that's going to equal 6. And we can go ahead and prove that this works this way. So let's take it this way. So we have log base 2 of 8 squared. So there's nothing that's stopping us, other than it's easier to do it the other way, from just taking this as 8 squared. So 8 squared, let's go ahead and rewrite this. So log base 2, 8 times 8, which is equal to 8 squared, is going to be 64. So then 2 to what power is going to give us 64? And while that's a little bit trickier, we can go ahead and say that 2 to the 6th power is going to give us 64. So log base 2 of 64 is going to equal 6. And that's how we do the power rule. I would like to take this time to thank you for watching this video. If you have any other math-related questions, please feel free to drop them in the comments down below or email them to me at aankrum.tutoring@gmail.com. Listed below are some of the subjects that I feel comfortable tutoring in. Once again, thanks for watching, and I hope you have a wonderful day.